site. My name is Tao Yan. I come from the Blockchain and Distributed Ledger Technologies Group. And today I'm going to present this topic, Optimizing Arbitrage Opportunities on Uniswap. This is the outlook of this presentation. Let's first go to the DeFi and the Uniswap introduction. I think some of you already know DeFi and the Uniswaps. So here I would just want to make a reminder that the DeFi after the reached peak in 2021, now from the plot you see, it comes to back to as currently the crypto market becomes more active and the price start to rise again. So among all these decentralized exchanges, Uniswap is a leading platform. Here we calculate the market share of Uniswap among all these decentralized exchanges. It has a decline trend, but still up to the early of this April, it still accounts for around 27% of all decentralized exchanges. So it is still the largest decentralized finance protocol. Uniswap is different from the other centralized crypto exchanges, such as the Balance, which are based in Singapore. But here, Uniswap, it used the automatic market makers to for trading and making and decide the price. So users, if they want to trade on the Uniswap, they didn't trade with users directly on like the peer-to-peer trading, but they are doing this peer-to entity trading. So the entity is this automatic the market maker. Also, the price is simply decided by the ratios of the tokens inside of a liquidity pool. So here we use X represent the token A in the liquidity pool and Y represents the token B in the liquidity pool. If we calculate the price B is just the reserve of token A, which is X divided the reserve of token B, which is Y here. It's very simple for the mechanism, but it's very efficient and valid in the actual situations. Here, we will not want to give you more like this number values to show how the power of Uniswap. Instead, we try to give some overviews from the network perspective. So what we did is we represent the Uniswap, the market, as a network. Inside of the network, each node represents a token, and each edge represents a liquidity pool. Here we have the visualization of the Uniswap market in the early stage. If we comparing the Uniswap networks at different times, we basically find that the Uniswap market becomes more centralized. So here in the right side, different colors represent different communities inside of this network. And you can see the largest component becomes larger than the previous plot. So generally, this network becomes more centralized. So furthermore, we want to know at which aspects this network becomes more centralized, and we investigate the degree distribution and the TVL of token distribution and the TVL of pair distribution. All of them follow the parallel distributions. So that means in terms of these three metrics, this Uniswap network are becoming more centralized. And we also want to furtherly know if there are some tokens or liquidity pools, they are dominant this market. So we used the betweenness metric in the network to measure the centrality, the centralization in this network. So the results showing, if we're considering the dominant tokens, we find still the tokens with very large TVLs, they also have very large the central betweenness values. So here we have the wrapped ether in the upper right side, and also we have the USDT, USDC. Both of them, they have very large TVLs. They also have a very large betweenness centralities. But if we're considering the pairs, which are liquidity pools in the right side, they didn't show the same phenomena. If we can still consider the top five pairs, they are not have a very high betweenness centralities. But on the other side, we find some liquidity pools. They have smaller TVL values, but they present a very large betweenness values. So this situation is different from the TVL of the tokens. We also find there are some core periphery structures inside the network. If we first considering to identify this core periphery structure in a static network, which is on August 28th of 2023, we find there is a 18 core periphery structure, and also comparing the random network, we can confirm this core periphery structure exists in this network. And from dynamically, we also check if this core periphery structure they present all the time, and also if they how it involves. The result shows this core periphery structure becomes more prominent over time. So our short conclusion here is that from the both static and dynamic features, this network shows there are some dominant tokens and peers on this market, and it becomes more centralized. This is the first part of this presentation, and then we want to go to the arbitrage analysis. So maybe you are still wondering why we construct this market as a network. Besides just investigate these features, I think there is a very good usage for this network is for the arbitrage analysis. Arbitrage, you can do it on different marketplaces. So the idea to do the arbitrage is very simple. Is just you find some deep price differences on different markets, and then you buy the token in the market which has a lower price, and sell the token on the market where has a higher price. So idea is very simple, but on the Uniswap, there can be another different scenario, which is that besides just check the token's price differences, and you check the price differences among the trading pairs among multiple trading pairs. If you already have some knowledge about the arbitrage trading on the foreign exchange, maybe you already know something about the cyclic arbitrage passes. Here I presented an example which shows what are these cyclic and arbitrage opportunities on Uniswap. So here we have an example which you start from the token wrapped Ether, WETH, and you go through USDT, SLC, and DAT, and finally you come back to the WETH token. Along the cycles, you have the price, which is a weight, which is a property of the age, and you multiply these prices. In the left side, we have a formula which shows the process, and you will find if you invest 1 WH, finally you will get 1.2 WH. So you get more and you make the profit. In general, so we can use this formula to represent the conditions of arbitrage opportunities on Uniswap. After constructing these cycles, along the cycle, you have the price of tokens, which are the reserve ratios of tokens in the age, and you just calculate the product of the token prices along the cycle, and also you subscribing the swapping fees, which is numbered here. So for each trade on the Uniswap through each liquidity pool, you need to pay a transaction fee, which is called swapping fee. It is 0.3% on Uniswap V2. And then finally, you make these two components together. If the product is larger than 1, it means there is an arbitrage opportunity. To conduct the research, we collect the data. Let's see how much time left. Okay, I still have enough time. We collect the data from unarchived load, which we are running in our group, and we get the data at a specific block number, which is this number. There is no specific reason. It's just because this our archive load at that time stopped at that node, and we didn't sync the load, and we collect the data for the native status of the our archive load. This block number corresponds to August 28th of 2023, and the data collected from the load is just the event called think event. The think event represents the reserves of the liquidity pools after each transactions on Uniswap. So to use these think events, you can simply construct the networks and their reserves at a specific time. But here there are two reminders. The first is that if you're considering a single block, maybe not all these liquidity pools, they have trades on this single block, but you need to include all other liquidity pools which are not traded on this block, but they are traded before this block number. And also for each liquidity pool, they can have multiple tradings at a specific block. And here you need to connect the latest sync event at a specific block to get the current states of the liquidity of this pool. And this table shows the data fields we used in this research. So here comes the research questions. What we are going to study is that how can we identify the arbitrage opportunities on Uniswap? I think this topic is started by the previous work. So what our focus in this work is, we want to check if we increase the arbitrage partners, if we can get more arbitrage opportunities and also get more profits. And finally, this can come to another higher level research questions is that, is Uniswap an efficient market? If it is efficient, you will not outperform the market to get extra profits. But if there are multiple arbitrage opportunities exist, so it basically means this is not an efficient market. So to find these arbitrage opportunities, the first step we did is detecting cycles from the network. So after constructing this network, we start from a token called wrapped ether. Why we started from this token is because from previous research, we found that more than 94% liquidity pools, they are paired with this wrapped ether. So if you start with wrapped ether, you will find more connections and you will find more cycles with larger passes. And also we have another parameter to decide how deep, how long we will go when we find these cycles. So we have a predetermined length. In this research, we limit this range from 3 and to 8. So we will find these cycles as 3, which have 3 lengths and up to 8 steps. So after detecting these cycles, for each cycle, we perform this calculation to find if they have these arbitrage conditions. If they have, we keep them as like potential arbitrage passes. But different from the traditional market, there is a very different situation is that still Uniswap is an starting market. So there are not enough liquidities. The slippage is usually happening on this market and is more serious than the traditional market. So here, what are the slippages? From the plot, if I want to trade, there is an expected price, which is represented by the blue point. But actually, because Uniswap used this AMM mechanism, the actually executed price will be in the red point. So if you calculate the differences, the difference, if you use P1 subscribes the P0s, you will get the slippage. And this slippage is like represents your trading, how your trading will affect this market. And if you do some math deduction, you will find this slippage is actually the amount, the ratios between your trading amount and the liquidity pools. So delta X divide X, this represents the slippage you will get from your tradings. But there is another situation, which is that your trade will result to this slippage. And also there are other traders in the market in the meantime. Their trading will also lead to this slippage. And depending on their trading directions, sometimes their trade will give, most of the times, their trade will lead to a worse slippage for a trader. But sometimes their trading will have a provide a better slippage, but this is seldom happen. And finally, after considering this slippage and identify this arbitrage parses, and we need to decide which amount we need to invest. And thanks to my collaborator, Yu Zhang, and he did this part. And so there is a mathematical model to calculate this optimum input amount. We observed from this trading parses, the input amount has a relation with this output amount. From the plot, you can also observe that there is a convex and monotonically increasing pattern. So if you increase your input, and you will get increase of your output, but the ratios becomes smaller. So to find this best point of the best input amount, we just use this marginal input should equal the marginal output. And to solve this equation, and we can find this best point of the input amount. The final step is to taking into account of the transaction fees. It's very important to consider the transaction fees when you are doing the arbitrage. But here, because we identify a lot of these arbitrage opportunities, we can't exclude them in the real environment. So we cannot get the excluded transaction fees. What we did is we have an estimation of the transaction fees between the transaction amounts for each transaction on Ethereum. So here the estimated transaction fee on August 28 of 2023 is 0.00039 wrapped Ether. So we use this transaction fee to represent all the transaction fees will incurred by our tradings. There are some results. The first is we visualized the arbitrage transaction, triangular arbitrage inside of the network. So from WETH and to USDT, and then to TX, and finally come back to WETH. This is an arbitrage parse. More importantly, we found totally we detect there are 800 triangular cycles, but finally we only find 35 passes can achieve profits that will cover the transaction fees. So from the current results, we found that the triangular arbitrage, which are very popular and common on other markets, but they are very scarce at recent blocks. So if with the block increasing, this triangular arbitrage will becomes more scarce. So this reminded us to think if we can increase the arbitrage parse length, if we can find more arbitrage opportunities and profits. In theory, from the perspective of probability, if you increase the length of the arbitrage, there will be more arbitrage opportunities. But sorry, here I didn't put the slide to showing this probability, the formula. And here we have this visualization of the 6 steps arbitrage parse. This is a larger parse than the triangular arbitrage. And also we calculate for the number of these arbitrage opportunities along each cycle length. So from this plot, it shows with the increase of the cycle length, there are three kinds of the cycles. The first is the total cycles. It increased. And also the profitable cycles, which has a profit larger than 0, they also increased. Most importantly, we found the profitable cycles, which are in the green color. They can cover the transaction fees. With the increase of the cycle length, they also increase. But that is not enough. This just shows we can find more arbitrage opportunities with the increase of the length. But we also want to know if we can find more high profit arbitrage lengths. In this case, we calculate the profit. This plot shows the profit distribution at each length. So in general, if you're looking from the length 3 to length 8, the median value of each length profit, the median value profit at each length, firstly has increased, but up to the length 5, and then it decreased again. So here it means if you want to find this high profit arbitrage parses, which length you will go. This plot gives you some hints, which is that you can try at the length 5, because at length 5 you have a larger probability to find the high profit arbitrage, to find the high profit arbitrage lengths. And maybe I think actually the traders will not just hear about the trading opportunities which will cover the transaction fees. They are more curious about the high profit opportunities. So here we define the high profit as the profit which will greater than 0.1 wrapped ether, roughly around 300 USD dollars currently. So they are the high profit arbitrage opportunities. And also we visualized their how they will evolve with the length, with the increasing of the length. From the right side, the number of these arbitrage opportunities also increase. But from the left side, if you considering the median value, which is a white point, it also has a decline trend, and it decrease more significantly than the previous plot. So here there is a trade-off between this number of arbitrage opportunities and the profits. Basically means if you are trading using these strategies, you need to decide on which length you want to get more cycles, and at which length you will have a higher profit. So there are some take-home messages from this work. The first is the triangular arbitrage opportunities are scarce at current block. But if you increase the length of the arbitrage parts, you will find more opportunities. In the meantime, with the longer parts, you will have less profits in general. So once again, there will be a trade-off between the profits and the number of opportunities. But actually, if you want to use this strategy, the situation, the market, it will be very complicated. So we're just doing the research. We didn't provide these investment strategies. So because we tried to execute these transactions in a simulation environment, unfortunately, some transactions we identified, we can't execute them. So it returns error. We don't know the reason, but she shows this should be very complicated inside of the real market. Thanks for your attention.